Hello everyone. In this video, I am going to talk about section 4.6, moment of a couple. A typical application of it would be whenever you're driving your vehicle, when you grip the vehicle's steering wheel with both hands in turn, the couple moment is applied to the wheel. Starting with the definition, a couple is defined as two parallel forces with the same magnitude but opposite in direction, separated by a perpendicular distance d. The moment of a couple is defined as scalar analysis F times d, m equals F times d. That will be the scalar analysis, or using the vector analysis, we have m moment equals r cross F, r being the position vector, F being the force vector. The net external effect of the couple is that the net force equal to zero. We know that the force are equal on the magnitude in opposite direction. So net force equal to zero. However, the magnitude of the net moment is not equal, it is not zero, that equals to F times D. Since the moment of a couple depends only on the distance between the forces, the moment of the couple is a free vector. What it means is that it can be moved anywhere on the body and have the same external effect on the body. Moment due to couples can be added together using the same rules as adding vectors. Let's take a look at our first example together. We have two couples acting on the beam, this rigid body. So really we need to separate them. We have two couples here. Let me use a color code. First couple is this F and this F. That's a couple. And the other two, we are going to look at this 2 kilonewton and this 2 kilonewton as a couple. Okay, so we're looking for the magnitude of the F so that the total resultant couple moment is 1.5 kilonewton meter clockwise. So let's put them together. We have that F, we don't know how much is what we're looking for. And again, starting this symbol right here is says we are going to define counterclockwise as the positive direction. Since counterclockwise positive direction, this F, I am going to kind of like make a loop. Okay, and then follow the direction of these two forces going this way, meaning this couple, the green one right here, is generating a clockwise couple. It's going to be negative. Okay, so that's why you have negative F times the distance between them, which is zero point 0.9. And then the other one, 2 kilonewton, I will do the similar thing, sort of making a loop with them, and then follow the direction of that arrow. This is going to be counterclockwise, meaning this 2 kilonewton is going to be positive moment because it's trying to rotate counterclockwise. So putting that together, negative F times 0.9 and then that 2 times 0.3 positive. Together, they're supposed to generate a 1.5 kilonewton meter of moment, and it says clockwise, meaning this 1.5 kilonewton meter needs to be a negative value because it's clockwise. Okay, so that's where that negative comes from. We have one equations and one unknown. Solving for the value of F gives us 2.33 kilonewton. Example number 2 says we have a 450 Newton force couple acting on the pipe assembly. We're looking for the couple moment in the Cartesian vector notation. So we're going to use moment equals r cross F. Okay, we're looking for the position vector RAB, position vector. Remember we say ending point minus the starting point. So if you get lost, please refer to the several videos in chapter 3 that talks about the position factor. Next thing is the FB. FB, we are breaking them into the X, Y, and Z component, which is our IJK component, right? So again, if you get confused with that, refers to the previous chapter. We talk about how to break them down. Put them in this matrix form, or have RAB cross FB. Putting in the matrix form, and we're looking for the determinant. Comes out to be this much. You have your I component, J component, and K component for our moment altogether. Okay, so hope that helps you. Next one, we're looking at this group problem. These, they have couples. Let me color code them. The 80-pound and this 80-pound, yes, they are a couple. And then because they are parallel. And also I have this 50-pound and this 50-pound, they are a couple. They're parallel. Now, they are not horizontal or perpendicular. Well, I'm going to need to break them. I am going to need to break them into the horizontal and vertical direction. So that 80-pound, I'm going to break it horizontal, and this one horizontal, And it's also got the vertical component. Vertical component is going to be this much and this much. And I want to tell you that the vertical component does not generate any moment because they are on the same line of action. They are both vertical. They are on the same line of action. And it's not going to, the vertical component of that 80 pound will not have the tendency to rotate. Same thing as that purple one. So the vertical, that one's got a vertical, it does. This one, the purple one, the vertical does, but the horizontal, excuse me, horizontal one, it does not generate a couple because they're on the same line of action. Okay. So again, that 50, we're breaking down into the vertical and horizontal, right? The vertical component, yes, it's generating a moment. Vertical part of it, yes, it's generating a moment. But the horizontal one, it's not because they are on the same line of action. They kind of going toward each other and cancel out. Only the this one, 43.3, which is the vertical component, is generating a moment. And then same thing, that's the 80. We're breaking that 80 into the horizontal and vertical component, and only the horizontal component that is generating the couple, the moment. Okay. So we're going to put that together. You have that vertical component of that 50 times the distance between them, which is 3 feet. That's where that comes from. And this thing, if you follow the direction of that arrow, it was vertical. This end was vertical. You're going this way. That is going to be clockwise. That's why it's negative. And then the blue one, the 80 and the 80, the horizontal one is generating a moment. Vertical one does not. So you sort of follow the direction of that arrow. You're going this way, that way, that way, that way. That is going to be counterclockwise, which will be a positive. Also, okay, so that's where that 64 times 4 feet, 4 feet is the distance between them. See right here, from here to here, that is 4 feet. Okay, and then 64 comes out from the 80, for 80 times 4/5. Only the horizontal component of that 80 is generating a moment. Putting that together, one clockwise, one counterclockwise, putting that together, be careful with the sign. We have 126 for counterclockwise together. Next group problem, I have force 80 going down, and the other force negative 80, meaning I have that positive 80 is the one that going up, negative 80 is the one that's going down. So we're looking for the couple moment acting on the pipe assembly using the Cartesian vector notation. Again, we're going to do the m equals r cross f, r being the position vector from A to B. Okay, be careful with the position vector, ending point minus the starting point. So we have our position vector, which goes to your first row, and then the second row will be the force vector. Since it's pure vertical, force vector, since it's pure vertical, that's why we'll only have 80k, the k value, only on the k direction, the z direction. And then we're doing our, looking for the determinant of this 3 by 3. That gives us the result of the moment overall. Okay, this is all I want to show you in this section. Hope that helps you. Please let me know if you have any questions. Look forward to see you guys on our Friday sessions. Have a good one. Thank you for watching.